Hello, I'm Tianpeng Shu. I finished the project just by myself. My project title is Employer Tuner Data Analysis. It includes series points. The first is uh, initial task. The two is data employer and processing. Then is descriptive statistical analysis. The four is distributed analysis and relationship exploration. And the five is regression and ANOVA. Six analysis finally is conclusion and outlook. The job is about the job is to it's about employer. I want to get why the employer will get a new job, and I work for my company, and I manage a department. So I think it is useful for me and for my company. The data side is from Kaggle. The name is Explorer on the prediction this data set. And which was the data set, the most important is race. It is enough. It, it's uh, it's over 9,000 uh, data. And the data set is just upload at January 23 in this year. There is data in Power and Perface. There are 26 variables, but we just analyze the main variables because some variables is not important for our purpose. Uh, uh, we will analyze the tree hours, income, months and years, and local house, job awareness level, and other important things like the pattern of the memory and marital. Like first, we use the hard and still get the best information about this data set. And it is lucky for me because the data set is cleared, so they are not mass values, and the all of the value data set variable data set data table is correct, is right. So we need to uh, to clean the data. We can use it. There is a descriptive statistical analysis. Mm. We use the summary to get the mass, mean, query, and mean of mean. We can know all of the variables. Then we use the box plot to further observe the data distribution, and we can get the some noise of the error variable. Um, but but they are not noise data. Then then is the distribution analysis and the relationship exploration. It's important. We must special observatory were made on some key variables. We use two type of the charts. Uh, charts. There is some examples. Then we use the pi to observe the retail. For example, the marital or the gentle or the development this distribution distribution. We can get some video from this charts. The most important, if we want to get the reason why the employer want to get get a new job, we should analyze all the variables. At first, we use a person coefficient to test the relation between all the variables. But all the result is small, like uh, here, like the 0.009 or 0.014. I think all is small, so it means uh, the correlation between the main variables is not high. Then we have other tools to test it. Finally, we chose the t-test and square. It is a code. It is some code. It is some code. The result of the code is like it. The the t test result t value is small and the p value is 0.996 3, which value is larger than the commonly used uh, significance level such as 0.055. So we consider it they are not significant difference in the ordinary small increase of the employer with and without loss. Use this code. I use the t-test and the custom test test the kin variables. The result is not good. Maybe all the kin variables is no signification correct between the turnover. It is better used for me because I try build a model to analyze the design. Then I use the linear uh, regression and the random forest, but they are not good. The RC is about 0.452 or 0.53. It is small. Yeah, like the gas, just a little good than the gas. Then I use the other fiction like the SMOTE or the swapping or data white adjustment or just adjustment to the formulate. But all of this is not usable. Consider the model is the most able to predict analysis who live. It may be that the the characteristics of the data set itself are not sufficient to support prediction, and maybe the data set is not good enough. Then I use the ANOVA to test the data set. I want to know it's really the data set is really good. Um, good. And before the ANOVA, the important thing is there are two consultation before the ANOVA. The first is the data must be the normal distribution. Because our data set is large, over 5,000, so I use this test to test it. And the result told me is the data set is not normal distribution. So it is not record for the actual operation to use ANOVA on this data set, but because you get requirement, I must use ANOVA. Although all video variable in the data set is not normal distribution, I will use it. It's code and the result. The result is the f is 1.31 and p is 0.2644. It means that the deployment filter has not a significant impact on the performance score. Then I test other variables, but not but it all of the mean uh, then there are no significant improvement uh, uh, on the score. Mm. So maybe after the ANOVA we can get the results. Maybe the dataset is bad. Okay. Okay, it's going to use for me. Me is not my worry. And then is a conclusion and outlook, which I showed in-depth analysis of the other potential influencing factors and employer of more effective data set and a modeling mass. And I will and if chance if, in the future I will get other decide to employ the reason why who the about the employer who will leave. It is important for me. I say it at the first because I have my department. So I will get the new design and new model mask to analyze the reason. It's all okay. Thank you.